Hello guys, let's find out why when trying to find the inverse function of a function, we interchange the role of x and y or simply interchange x and y. Well, before that, let me give you a quick introduction to inverse function and some of its property. It will be quick, I promise. So inverse function of a function is basically a function that just undoes what that function did. Let's say you have a function that took a number 2 and made it to 5. For example, y equals to x plus 3. Now, basically an inverse function, what that does is take that 5 and make that into a 2 again. And here, using that fact, we can generate two properties, and that is that the function of the inverse function of any number, let's say x, this will just give out x, and like this. And why is that? Well, look at what's happening. We're taking a number, changing that into something, but at the same time we're taking that something and bringing it back to the original number. So if we start with x, we'll end up with x. And since these two are inverses of each other, we can change their position like this, and this will still give us x. So we can use this property over here to kind of find out how we can generate inverse functions. We know that we have to get only x somehow. So from any function, we just need to isolate x. We need to put in something in terms of x in the place of x in that function, so that we only end up with x. It doesn't matter if it's as simple as x plus 3 or very long and complicated, we just want to end up with x. So one way you can do that is here. As you can see, we have y equals to x plus 3. So we change 2 to 5 and we want 5 to 2. What you can simply do is subtract 3 from both sides. And as you can see, we have successfully isolated the x over here, which is what we want. So we know that our function is y minus 3. We put that in here and we'll get x. But wait, I said we need something in terms of x, but this is that something but in terms of y. Because here, put that in place of x. You'll get, let's ignore this y equals to, well, actually we don't have to. You'll get y equals to y minus 3 plus 3, and as you can see we end up with y equals to y. But we need y equals to x. So here is the fact that will help you. We interchange role of x and y because at the end they are just dummy variables. They can be interchangeable and they will change nothing because simply they are just numbers. This will have a number and make that into another number, and that is it. They can be interchangeable. So at the end what you can do is you will write x minus 3 equals to y, and this y is not our original y, don't be confused. So in fact we cannot even write this, so I'll put y prime. Now this in fact is our inverse function, because you can just put that back here and this will be just y equals to x minus 3 plus 3, right? We're putting this in place of that, and as you can see we end up with y equals to x. So we can verify that our inverse function is indeed x minus 3. Now what you guys may have noticed is that we interchange the role of x and y at the end. We isolated x and got that, but typically when doing finding inverse functions, we do it at the beginning. But that's just for convenience. That's just so it wouldn't get confusing. And well, as you can see, we have y equals to x plus 3. We interchange them first, x equals to y plus 3. And now after interchanging, the second rule is we're trying to just isolate y. So we'll get y equals to x minus 3 like here, and boom, there is our inverse function. Finished. And let's say even for y equals to x square. Now for this, we know that the inverse function of squaring will be the root, and we interchange the position and we square root, we'll have this, and that is our inverse function. You cannot do that as well. You can directly do it over here. You get x equals to root y and then interchange their position and you'll end up with the same thing. So that is why we interchange the role of x and y. And here, sometimes the functions can be really hard to find their inverse functions of. For example, let's say you have y equals to x squared plus x. Now, let's say you interchange. So you'll get x equals to y squared plus y. Now from here, how will you just isolate y? Well, you can't do minus y and then root, because you'll have y equals to root x minus y. So there's a y in the other side as well. But what we can do is, we can just complete the square. So for here, we'll have x square plus, well, we have our a square for the a plus b whole square, which is a square plus twice into a into b. So we can determine what our b is from here. Well, in fact, I'm using y, so I'm going to use y, and I'll clear this up over here. Now, this is our function, and this is where we're up to. Now, as you can see from here, we only have y, and if we multiply it by 2 to get just 1, we'll have to divide by 2, and that is essentially our b for a plus b whole square. So we know we need to add 1 by 2 whole square. But as you can see, we just introduced this term over here randomly, so we must subtract it over here. Now, this will be a square, which will be y plus 1 by 2 whole square minus 1 by 4. And now we can finally isolate y. Just add that to that side, you'll have this, so y plus 1/2 whole square. And now you can just square root both sides, so you'll have y plus 1/2 equals to x plus 1 by 4 whole root. And finally you'll get y, which is our inverse function, equals to root x plus 1 by 4 minus 1/2. Now let me just quickly check. Wait, I forgot one thing. When you rooted this could be plus minus. So you have to be kind of careful with that. Now yes, this is not a strictly inverse function because there will exist two functions, the plus and minus version. But I guess you guys have to check on your own and input a number, get that number, and putting in the plus and minus, you can check which one give the original number back. And if you would like, you can just put this in place of x, this whole thing over here, and you should end up with x. And another fact is, you can also use the quadratic equation. So from here, you can use y squared plus y minus x equals to 0, and you make this minus x as a constant. And using the quadratic equation, you can directly get the inverse function actually. So you'll have y equals to, this will be minus 1 plus minus root b square, which is this, minus 4 into that, which is 1, into minus x, which will be plus 4x, by 2 into 1. Now, this and that looks different. They looks kind of not similar, but you can do some simplification. You can separate these two. You'll get minus this, plus or minus root 1 plus 4x by 2. And what you can do is, here you can put this 1 by 2 inside the square root. So in fact, I'll write it as root multiplied by 1 by 2, which is the same thing as 1 by 4 whole root. And as you can see, since the two are roots and both positive, you can write it as 1 plus 4x by 4. And then again you can split further, so you'll get, here I'll put this plus or minus front, root 1 by 4 plus x minus 1 by 2. And as you can see, they two are the same. You can just swap them, doesn't matter. And yep, there we go. We solved the, well, not solved, we found the inverse function of a hard function to find the inverse function of. Now for cubic equations and polynomial equations, it can get more tougher because, well, the cubic equation, you can just forget about that. You can try to complete the cube, but it will be much tougher. And I almost forgot to mention some functions. Well, exponential functions and logarithm functions. Well, simply they are inverses of each other. So let's take y equals to e to the power x. the inverse function of this will be ln of x or log e of x. Now, for the inverse functions of such exponents, the inverse function will simply be the logarithm of the base of x. So let's say you have y equals to 3 to the power x, its inverse will be log base 3 of x, and so on and so on. And that is how you can find inverse functions of exponents and as well as for logarithms, because if their inverse is this, then its inverse is this. That is it. That is all I forgot. And if you guys learned something new, please like and subscribe. Thank you.